Perfect. Okay.
Oh, yeah, I just want to welcome everybody for attending too. I forgot to say that. It's nice to see
Awesome.
you all.
Okay. Am I good to go,
Yep.
Isabel?
Yeah, you're good. I see everything there.
Okay, great. Okay, thank you guys. Thank you to Isabel for having me present at HAP 2.0 today. So again, my name is Holly Deighton and I am a forest research intern with the Ministry of Northern Development, Mines, Natural Resources and Forestry. I'm just finishing up my contract with the ministry. My last day is on Friday and I just started a PhD actually at Western. So I've been busy this month. So thank you guys for taking this hour to come listen to what I've been working on today. And I'd first like to acknowledge that the work that was done today was on lands traditionally occupied by Indigenous peoples. They continue to care for this land, they continue to shape Ontario today, and I really wanted to show my respect. Hundreds of years after the first treaties were signed, they are still very relevant today. So thank you for that. Today I will be talking about a paper that I published in the journal Forests in January, entitled Trade-offs Among Released Treatments in Jack Pine Plantations, 25-Year Responses. So I would just like to thank my co-authors on this paper, Wayne Bell, who I thought was going to attend today, he might be a little late, Nelson Thapo, who we have on, Eric Cyril, Matthew Leach, Mahadav Sharma, and Jennifer DaCosta. So I'd like to thank my co-authors for making this project possible. So I'll first go over a little bit of background, and then we'll jump into the actual meat of the project, the results and the implications. So ecosystem services are resources and services derived from nature that bring benefits to humans. And these resources and services contribute to making human life both possible and worth living. So we can break down categories of ecosystem services into 4 categories. So the first being provisioning services, which are the supplying of goods of direct benefit to people, such as food and fiber and biochemicals. Then we get regulating services, which are the range of functions carried out by ecosystems, such as climate regulation, water purification, and pollination. We also have cultural services, which contribute to the wider needs and desires of society, such as education, sense of place, and cultural heritage. And finally, we have supporting services, which are very essential to the functioning of ecosystems, such as nutrient cycling and soil formation. So forests can provide an array of ecosystem services while helping to offset greenhouse gas emissions, but they are affected by natural and anthropogenic disturbances, as well as climate change. And these disturbances can interact with climate change to modify forest composition and productivity, thus affecting the capacity of forests to sustain services such as supplying wood or maintaining biodiversity or any of the other ecosystem services that I talked about previously. So successful stand regeneration can mitigate these effects and is a very and is keystone to sustainable forest management. So in Ontario, all harvested areas are required to be regenerated to provide for the sustainability of crown forests in Ontario. And while natural regeneration does play a substantial role in forest renewal in Ontario, for example, about 44% of the area harvested in the past 20 years in Canada was regenerated naturally. The use of assisted regeneration or plantation forestry to regenerate specific species compositions can offer added advantages for supporting sustainable forest management in Ontario. So natural regeneration ensures that only trees suited to the site are established and is really low cost, but it may take longer for species, for forests to grow back and can result in stands that have species other than the desired species that we would like. Whereas artificial or assisted regeneration is more expensive than natural regeneration and requires a lot of seed for direct seeding and planting stocks, but it could allow for more to sites to grow more quickly back and allow forest managers to focus on desired tree species with good genetics to grow a really healthy forest. So the species we'll be discussing today is a conifer, a jack pine. which is a pioneer species, and it grows in even-aged pure or mixed stands on less fertile or drier soils, and it represents about 25% of Ontario's annual harvest. So vegetation management in conifer-dominated stands is typically done to maintain conifer compositions and increase conifer yields. And without vegetation management, pure jack pine stands can be converted to mixed wood softwood or mixed wood conditions due to ingress of trembling aspen. So I'm going to be talking about this project was established in the Vegetation Management Alternatives Program was established in 1990 by a past employee of the ministry, Robert Wagner, with the goal to develop approaches to maintaining forest vegetation that would gradually reduce dependence on herbicides in Ontario's forests. And the project I'm talking about today is part of that VMAP program. So in Ontario, conifer release is often accomplished with one aerial application of herbicide. However, increasing public concern about herbicide use in forestry has led to research focusing on alternatives. So the application of vegetation management treatments such as herbicides or brush saws involves making trade-offs between certain criteria such as biodiversity or productivity. And while it's often expected that herbicides can reduce biodiversity, some studies have shown that herbicide applications do not typically result in species loss. However, they do result in shifts in abundances and evennesses. And empirical studies have generally supported the notion that forest vegetation release treatments do not generally produce tree monocultures. However, under some conditions, stand scale tree monocultures can develop from multiple herbicide applications. So longer term studies are needed to determine if these patterns are persistent in older plantations, such as the one we're going to talk about today. So international agreements such as the Montreal process provide opportunities and set challenges for forest managers worldwide. The Montreal process is an internationally agreed upon framework of criteria and indicators that has been implemented across 12 countries and ranges from scales from local forest management units all the way up to international levels. And it accounts for 90% of the world's temperate and boreal forests, with the goal of sustainably managing temperate and boreal forests. So you can see they have 7 criteria and 54 indicators. We'll be focusing on the first 2 criteria today, the conservation of diversity and productivity. So again, the application of vegetation management treatments such as herbicide or brush saws involve making trade-offs between certain criterion, such as biodiversity and productivity. And best forest management practices must address these competing demands, such as successful growth of crop trees following aerial herbicide use or increasing public concern about herbicide use in forestry. So this takes me to the study objectives, which were to compare the effects of release treatments on jack pine plantations on 3 criteria: plant diversity, stand scale productivity, and tree scale growth and quality. And the first criteria goes along with the first criteria of the Montreal process, which is the conservation of diversity. And our second 2 criterion, the stand scale productivity and tree scale growth and quality, are under the second criteria of the Montreal process, which is productivity. So here I'm going to be presenting data from 2 sites that were established in 1992 and 1993 in Northern Ontario under the VMAP program. And this research, again, is going to address the lack of longer-term data needed by forest managers to implement more integrated vegetation management programs in boreal and subboreal forests. So the 2 study sites I'll be talking about are Bending Lake, which is a jack pine mixed wood forest and is a low fertility site located about 54 kilometers northwest of Atikokan, Ontario. And the second study site is E.B. Eddy, which is a mixed wood forest with fine sand silty loams, which is an intermediate fertility site, and it's located about 120 kilometers northwest of Sudbury, Ontario. So following clear-cut harvest and site prep in the 90s, both sites were planted with 3,000 seedlings per hectare of jack pine, which is equivalent to about 1.8 by 1.8 meter spacing. And then 2 to 4 years following planting, 3 treatments were implemented as well as a control at both sites. So here I just have all 4 treatments on the slide, ranging in treatment intensity from 1 to 4. So the first was a control, which is which was just post-logging vegetation was left undisturbed and left to grow naturally. And then we had motor manual brush saw treatment, which was where non-crop vegetation was cut at the ground level or 25 centimeters above the ground level in October, 1 year after harvest. Then there was a single aerial application of herbicide using a helicopter in August, 1 year after harvest. And the last was called a complete removal treatment, which was a combination of the single aerial herbicide application using the helicopter, as well as annual glyphosate applications for 3 years using a backpack sprayer. The fourth treatment is not typical of operational practices and is included as an extreme for the purpose of our study. So we hypothesized that following treatment application, the sites would increase conifer yield, conifer survival, growth, and conifer wood quality. And again, the conifer is just referring to the jack pine. And hardwood yields would decrease. And we didn't really expect anything to happen to plant diversity. It would remain quite neutral. But we also assumed that in the most intensive treatment, that extreme complete removal treatment, that plant diversity would decrease, meaning that abundances and evennesses may decrease or change. But we also didn't expect that the most intensive treatment to lead to tree monoculture. So just jack pine, we expected some other species to still be in there. So this is just a picture of a past student, Erica, taking a DVH measurement, 25 years post-treatment. So that is our methodology of our study. So these, 25th year post-treatment remeasurements were done in 2018 and 2019 at both sites, where we assessed 27 indicators of plant diversity, stand scale growth and yield, and tree scale growth and quality. So all 27 indicators are shown on this slide. I won't list them all individually now, as we're going to go over them in a little bit more depth later on. So while I present the results, you guys are going to see these spiderweb looking diagrams, which are called radar diagrams. And you're going to see them for each criteria. So for example, for our first criteria, plant diversity, we had 10 indicators, starting with softwood richness and ending in evenness. So you look, it starts with softwood richness, you kind of go around it like a clock to evenness. So each criteria is going to be compiled as a percentage deviation from a baseline and portrayed in this radar diagram. So for example, if we're looking at softwood richness, if the highest softwood richness was 7, you'd see a line coming up towards like the edge of the radar diagram around this 100 mark. Whereas if we had lowest softwood richness, say the plot had maybe 0 or 1 for richness, it would be towards the middle of this radar diagram, towards this 0. And this will become more clear as we talk about the results more. So looking at criteria 1, plant diversity again, for Bending Lake, we're going to start with Bending Lake. We can see 10 indicators. So we have softwood richness, hardwood richness, shrub and herbaceous richness. Then we have some abundance indicators, and we have some other diversity calculations, evenness and dominance, etc. And we have 4 lines here. So we have a black line, which represents the control treatment. Then we have an orange dashed line representing the motor manual brush saw. We have the dashed blue line representing an aerial spray, and then we have a dark solid blue line representing complete removal treatment. So we can see that out of all 10 indicators, only herbaceous richness in the herbicide plots was significantly different from the control plots. So looking at herbaceous richness, you can see that these 2 blue lines, which represent the herbicide treatments, increased herbicide richness, herbaceous richness, as opposed to the control and motor manual brush saw. There's also some other small differences. Softwood richness tended to increase with treatments, and so did hardwood and shrub richness, but they weren't significantly different than the control. So then looking at EB-Eddy, we did see this very similar results at our second study site. However, the softwood richness in all of the plots tended to be significantly higher than those found at Bending Lake. So softwood richness, even in the control treatment, tended to be closer to this 100, this maximal or ideal site condition, versus Bending Lake. Same with hardwood richness, it seems to be increased in the treatment plots. So why was softwood richness significantly higher and hardwood richness the same or higher at EB Eddy versus our other site, Bending Lake. So at Bending Lake, the site was trenched, whereas at EB Eddy, the site was bladed. And blading left big berms covering a significant amount of the plot area at EB Eddy. And in these berms, jack pine were not able to be planted, and the berms were also not treated with brush saw. So we hypothesized that this left a very nutrient-rich area for other softwood or hardwood species to ingress and grow. And that's why we think that there was higher richness at EB Eddy. We also saw that hardwoods persisted even in the most intensive treatment plots, which did support our hypothesis as well, that tree monocultures would not develop after release treatments. And we assumed this was due to the fact that there was a lot of persistence in seed banks and more sprouting in the most intensive treatment plots. For instance, the herbicide applications with the backpack sprayer were only done for 3 years. And since it was only done for 3 years, we might have seen plant diversity, especially the hardwood species, decrease after 3 years, but after 25 years, we didn't really see any effects. And I think I was supposed to remove that slide. Sorry. Okay, so to summarize criteria 1, generally treatments did not change richness and abundance, as well as understory diversity. It really relatively remained unchanged. However, understory abundance in the herbaceous layer did increase. So moving on to criteria 2, stand scale productivity. Again, we're starting with Bending Lake, and we can see that there's 7 indicators for stand scale productivity. So we have gross stem, total stem density, conifer density, conifer basal area, and conifer inside bark volume. And then we also have some hardwood indicators, so density, basal area, and bark volume. And for this criteria, we see that all 7 indicators had a significant difference between treatment and control plots. So you can see for the conifers, for density, basal area, and inside bark volume, treatments increase these criteria for conifers, whereas the opposite was found for hardwoods. So hardwood density, basal area, and inside bark volume was highest in the treatment plot, in the control plots. You can see a very similar pattern for our EB Eddy site. However, we did see hardwood densities significantly higher than those found at Bending Lake. And again, we can probably equate this to those berms that I was talking about before, which left nutrient-rich areas for hardwoods to ingress on. So to summarize criteria 2, generally the treatments did increase conifer yield at both sites, but they did decrease hardwood yield. And looking at the last criteria, tree scale growth and quality, of the 10 indicators, 9 had significant differences between treatment and control plots. So going around the radar diagram, we looked at jack pine survival, total height, quadratic mean diameter, and then we have some wood quality items, so stem quality, which was rated on a scale of 1 to best stem quality to 4 worst stem quality, and we'll talk about that in a little bit. Then we had the percent of stems with good form, so the stems that had the best stem quality. And then we had height to live crown. Branching again was ranked on a scale of 1 to 4. Branch diameter, rings per centimeter, and merchantable volume. And you can see that survival increased in treatment plots for jack pine, as well as height and quadratic mean diameter. However, the wood quality measurements like stem and branching remained relatively unchanged in treatment versus control plots. You can see the same results for EB Eddy. However, I want you guys to look at the survival. Survival seemed much higher in treatment plots at EB Eddy, but much lower in control plots versus Bending Lake. So again, just to look at jack pine survival, you have for the control at Bending Lake, 48% survival versus the control at EB Eddy, 37% survival. However, at Bending Lake in the treatments, they didn't do as well. It was only 59 to 72% survival versus 78 to 85% survival at EB Eddy. So we can attribute this relatively low survival rate of jack pine in the controls at EB Eddy, likely due to severe competition from overtopping aspen. So after clear cuts without vegetation management treatments, intolerant hardwoods such as trembling aspen can recruit at high densities and can outcompete the jack pine. And once these jack pine are overtopped by things like aspen, it becomes increasingly difficult for them to get light, and that reduces their survival and height and diameter growth. So these results reinforce the assertion that forest managers that are aiming to increase jack pine growth need to uh, use vegetation management treatments. And also, temporary vegetation control was delayed by 2 to 4 years at EB Eddy and by 4 to 5 years at Bending Lake. And applying release treatments this long after harvesting allows for the establishment of understory vegetation such as like grasses and shrubs to outcompete shade-tolerant conifers such as jack pine, which can also decrease the crop tree survival. So the lower crop tree survival in treatment plots at Bending Lake compared to EB Eddy was likely a result of like the lower fertility site as well as delayed vegetation control. So I have a diagram here showing how we actually calculated stem quality on a scale of 1 to 4, 1 being the best stem quality, which was a normal or straight tree with no crooks or defects, and then all the way down to 4, which was the lowest stem quality, which was a stem with major crooks or stem defects. And you can see that the controls and treatments kind of stay in this area of 2 to 3 for stem quality, and stem quality was relatively unaffected by treatment. And the same thing really went with branch quality too, again, relatively unaffected by treatment, stayed around 1 to 2, which was a very fine or light branching. And none of them really had, none of the plots or sites really had heavy branching. Um, yeah. So, despite differences in height and quadratic mean diameter in our treatment plots, stand densities were below those recommended of 3,000 stems per hectare to maintain good jack pine quality wood. And planting densities of that 1.8 by 1.8 meter spacing that I was talking about is within the recommended spacing to maximize jack pine growth if all of the seedlings were to survive. However, that clearly didn't happen, and in our control plots, density mortality rates were high for jack pine, and again, it was possibly due to the ingress of aspen or interspecific competition for resources. So again, reaffirming that like site prep and vegetation management treatments are needed to maintain pure jack pine, near pure jack pine stands. And again, some problems that you're going to run into with low stand densities. So they can decrease jack pine height because individuals will allocate more mass to the branches when they are not competing for light. And increased allocation to branches for jack pine can lead to deteriorations in stem forms. And if you have optimal stem densities, the lower branches on the stem decrease in growth and can die from shading and competition. So then more mass is actually allocated to the stem, which increases stem diameter. And stem diameter is a really major wood quality attribute for the sawmilling industry. And when you have increased stem diameter, logging and manufacturing costs can decrease, and lumber volume, recovery, and grade can increase significantly. So we want to have higher stand densities. So to summarize criteria 3, generally the treatments increase survival and growth at both sites. However, stem and branch quality really remained unaffected. So research on the criteria and indicators for the conservation and management of boreal forests, not discussed here, such as like productivity, such as like socioeconomic benefits or maintenance of soil and water resources, is really needed to make informed policy decisions and continue to ensure sustainable forest management. And these assessments should, and given our observed trade-offs among vegetation management treatments for plant diversity and stand scale growth and yield and crop tree growth in form, it's highly likely that these treatments have trade-off implications for other ecosystem services. So future research is needed to understand these trade-off complexities, and future studies should investigate the effects of vegetation management treatments on the other criteria and indicators not listed, as well as at sites with higher jack pine densities. And that's all I have for you guys today. I'd like to thank all these people on the slide that made this project possible. Thank you.
Thank you, Holly. Just gonna try and get my view back up here. Okay. So does anybody have any questions? They actually, Holly, I saw Wayne log on just when you're about to start.
Okay, great.
He was
Yeah, I'm here.
Yeah.
Excellent presentation, Holly.
Yeah.
I enjoyed it. Okay.
Thanks.
It's really good. Yeah. Anybody else have any questions? Just jump right in or put your hand up. You can turn your cameras on too. I don't see anybody. Anybody? I go to
Yeah,
gas.
just Dave here, Holly. I had one method question just because I might have wrote something down wrong,
Okay.
and then I did have a second question. But the first one,
Hold on
early
a
in the
second,
slides
Dave.
when. Oh, yep.
Yeah, Nelson, am I stopping the recording or keep it for the questions? Oh, sorry, I can't hear you.
He's muted.
Yes, please stop the recording.
Okay, sorry, I didn't mean to. Okay, how do I stop? Pause.